is run through the beginning of the review packet. So I had asked you guys to do, I believe it was 1 through 5, actually 1 through 4, and then I'm going to work through a little more of the other ones. But let's talk about 1 through 4 for now. A lot of you, from looking at the answers, are on the right track. So here we go. I'm also, once I'm done going through the whole packet, I'm going to post my answer key as well, which is done up pretty neatly. So here we go. Find the average rate of change. Now remember, average rate of change is a fancy way of saying slope. So I'm doing y2 minus y1 over x2 minus x1. And right here are my x's. This would be x1 and this would be x2. So in the denominator, I know I have a plus h minus a. Now, y2 minus y1. y2 means I'm taking the formula and plugging a plus h in for x. So I'm doing 2 times a plus h squared. This is now y2. I'm going to put that in a bracket and subtract from it y1, which means I'm going to take this formula and plug in a. So I have 2a plus a squared. All right, so this is the setup. Now, right here I have to do a plus h squared. Now I'm going to do it up here. A plus h squared means I'm writing a plus h twice and distributing this. So we get a squared plus ah plus h squared, which is a squared plus 2ah plus h squared. All right, so now what I'm going to do here is distribute this 2. So I get 2a plus 2h plus h squared. So everything I just wrote here is y2. Bracket around it. Minus, so I'm going to subtract both of these, so I'm going to distribute the minus sign, minus 2a minus a squared. And in the denominator, the a's subtract off, so this is all over h. So h on the bottom. So if I subtract this, you guys should notice that 2a will cancel, a squared cancels, so that leaves me with 2h plus 2ah plus h squared. Now, what do all three of these have in common? They all have an h. So if I factor out the h, like that, these h's would cancel, and what's left over here is the answer. So the answer to number 1, which a lot of you did have, is 2 plus 2a plus h. So that was the answer to number 1. All right, next one. Now, a lot of you in this one were close, off a little bit in the final answer because you didn't finish it. When prices at $3 each, a toy has an annual sales of 4,000 units. All right, so when it's at $30, it sells 4,000 units. The manufacturer estimates that each $1 increase will decrease sales by 100. Okay. If X is the potential change in dollars from the base price, then the total revenue is this equation. All right, so that's how much money they're making. Find the unit price that will maximize. Maximum. All right, now let's take a look at this equation. If you were to distribute this, what would this become? So what I'm going to do first is take R of X, and I'm going to distribute this. So 30 times 4,000 makes 12 with 4 zeros. Right? Distribute the 30 minus 3, 0, 0. 0. X plus 4,000. X minus 100x squared. So if I clean this up, R of X equals, let's take a look at this, negative 100x squared. Combine these, plus 1,000x plus 120,000. All right, now let's think about this for a minute. X squared. What does an x squared graph look like? I hope you're thinking it's a parabola. Now, is it a happy face parabola or a sad face parabola? And because there's a negative out in front, It's a sad face parabola. So I want to find the maximum, which would be here. Now, how do you find the maximum point in a parabola? There's a couple ways of doing it. And what we're going to do now is we're going to start creating a worksheet. So you guys should be doing this on your own. This is formulas to know for the final. Formulas for final. And the first formula, oops, there you go, that we're going to talk about is how to find the maximum or minimum point on a parabola. And that is the axis of symmetry. The axis of symmetry will give me the line that goes through that point. And the formula for the axis of symmetry is x equals negative b over 2a. So this is the first formula you guys want to have written down on another piece of paper. Now luckily for you guys, this is a take-home final. So if you have this paper, you can use it as a reference when you're taking the final exam. So what I'm going to do now is use that formula to find that location. So now I'm going to do x equals negative b all over 2 times a, which makes negative 1,000 over negative 200, which is 5. So now I know x equals 5. Now, a lot of you have that written down as the answer. Not quite the answer. It's part of the answer. It says find the unit price that will maximize the total revenue. And if you notice back up in here, it says x is the change from the base price. What was the base price? Right there, $30 each. So if we're changing by $5, and that's the base price, then the new unit price is $35. And since we're talking about money, you should have a dollar sign in your answer. All right, so that's number 2. All right, next one. Consider this equation. We're going to sketch it. And I want at least 3 points. All right, now guys, this is a log graph. We just finished this unit. From the looks of it, a lot of you did get this right. But let's run through it. What I need to first is the parent function. Okay? The parent function of this guy would just be y equals the natural log of x. And anytime it's a log, we actually have to rewrite it. We're going to bend it. So what base would be here? E to the y equals x. So I'm going to make an xy chart of the parent function. Now look what's in the exponent, y. So that means we're going to put the numbers here. So do 1 negative, 0, and 1 positive, and that will take care of the 3 points that we need. So e to the negative 1 means 1 over e. E to the 0 is 1. E to the 1 is e. Right? So that gets us started. So this is the parent function. Now I want to do this guy. So now I'm going to do an xy chart for f of x. Okay. Right here, x plus 5. That means I'm going to subtract 5 from the x's. So this becomes 1 over e minus 5. 1 minus 5 is negative 4. And this would be e minus 5. We're going to talk about what that is in a minute. Then we have minus 3. So that means I'm going to subtract 3 from the y's. That'll be minus 4, minus 3, and negative 2. Now, what we also want to get for both logs and exponent equations are the asymptotes. What is the log asymptote for the original? So the asymptote, right, is going to be x equals 0. The new asymptote would be whatever we're doing to the x, or subtracting 5. X equals negative 5. All right, guys, so now I'm going to graph this. And I know x equals negative 5 is my asymptote. 1, 2, 3, 4, 5. Here's negative 5. And that's my vertical asymptote. I know this point, right? Negative 4, 1, 2, 3. All right. Now, let's talk about what this is, right? this is 1/3 approximately, right? Because E is 2.7, right? So 1/3 minus 5 means this is about -4 2/3. So at -4 2/3, I'm going to be at -4. Up there. Okay? And E, again, is about 2.7, right? 2.7 minus 5 means this is approximately -2.3. -2.3, and we're going to be at -2. So about there. So this graph looks like that. Voila. Remember, I'm asymptoting here. And that's good enough. We needed 3 points and the asymptote. So we're in good shape there. Now, state the domain. The domain is how far to the left do we go? Well, we went over to -5, but we're going to go up forever. That's positive infinity. A lot of you had that. And what's the range? We're going to go down forever, and we're going to go up forever. Now, it does say interval notation. That means these are the only appropriate answers you can give me. On the Google form, if you wrote all real numbers, I gave it to you. But on the final, if it says interval notation, you have to write it like this, or I take off points. All right. Next one. We want to sketch the graph of this guy. Now, this is what we call a rational function. This is a rational function. Rational in math is a fancy way of saying a fraction. And there's a list of work that goes with this. And if you do the list of work, it'll take care of all these situations here. So the first thing we're going to do anytime it's a rational function is to find the zeros or x-intercepts. Okay? That means what makes the numerator 0. So look at this guy right here. What would make 2 minus x equal 0? And that would be x equals 2. So that means we're going to hit the point 2, 0. And is there any way of making x squared plus 1 equal 0? No. Right? There's nothing. We're stuck with that. So that means we're going to hit the x-axis there. All right. So the first thing is we want the zeros. All right. Then we want the y-intercept. Now the y-intercept is what you plug 0 in for x. So I'm going to go through and plug 0 in for x. And I'm going to get 2, 1. Now on the bottom it would be 0 minus 0 plus 0. So that's undefined. So there's none. That means we're not going to hit the x-axis. Or the y-axis. I'll take that back. Next we have the vertical asymptotes. Okay. Vertical asymptotes are what's going to make the denominator equal 0, so I have to factor that first. Now, if you can't see it, the denominator is x cubed minus 10x squared plus 24x. So I'm going to factor this. So I pull out an x, right, and then factor it again, we get this. That means there's 3 different numbers where we can't, we're going to have under 3 of a vertical asymptote at x equals 0, x equals 6, and x equals 4. Now, what's important to know, right? Your intercepts are points. Your asymptotes are equations. And finally, the last step is the horizontal asymptote. And that's when we do limits. So this is when we're going to do the limit as x approaches positive infinity of this equation. Now, what's the most powerful thing in the numerator if you distributed it out? If I distributed the numerator out, we'd end up with a negative x cubed. That's the most powerful thing in the numerator. What's the most powerful thing in the denominator? That would be x cubed. So to find out what's more powerful, you do have to distribute out whatever's there. And this would reduce to be -1. And you would also test it in the other direction, which, I'm going to be honest with you guys, at your level, they're always the same. Okay? So my horizontal asymptote is y equals -1. So here we go. I'm going to start plotting this. So 2, 0, 1, 2, so here's 2. You always want to make sure you scale your number line, right? No y-intercept, that means we better not be hitting that. My vertical asymptotes. All right, we've got one here at x equals 0, at x equals 6. So here's 4, 5, 6, here'd be 6. So I have one here at 4, and at 6. Okay. And where's my black pen? I want to make this longer. Okay. And then I got a horizontal asymptote at -1. Let's make that -1. Now, if you guys remember correctly, the horizontal asymptotes only work at the edges towards the infinities. All right, now we got to start plotting points. Now, out here, we know nothing. So what we're going to do is plug the number 7 into that equation and see what we get. So if I plug in 7 into this equation, I get 2 minus 7, 7 squared plus 1. I like to use the factored version, right? So this would be the factored version. Actually, it's right here. So I'm going to write it with the 7's in it. You'd have 7, 7 minus 6, 7 minus 4. So that makes -5, 50, 7, 1, and 3. Now guys, is this answer going to be positive or negative? Right? It's -250 over 21. That's a big negative. So that means over here at 7, it's a big negative. So down here somewhere. All right. So now if I go to graph this, it's going to asymptote here and then have to follow the asymptote line there. So that's the first part. Now I have to do between these two dash lines. So I'm going to plug in 5. So again, plugging in 5, I have 2 minus 5, 5 squared plus 1, 5, 7 minus 5, 7. Oh, sorry, 7 minus 6, 7 minus. What am I plugging in? Plugging in 5. 5 minus 6 and 5 minus 4. So that makes -3, 26, 5, -1, 1. All right, so what that means is that I've got a big negative number over -5. They're going to cancel and make a what? A positive. I don't really care what positive. It just means it's up here in the positive region. Now, I know it's got to be up here because that counts to be positive. So it's got to look like this. Now, why do I know it has to look like a parabola? We're not allowed to go down because the only place we're allowed to hit the x-axis is right here. All right, next part. Let's plug in 3. So I'm going to do 2 minus 3, 3 squared plus 1, 3, 3 minus 6, and 3 minus 4. So that makes -1, 10, 3, -3, -1. So I have -10 over, I don't know, what is that, +9? So that's a negative number. So that means I'm going to be about there. Right? Now, why is that important? Well, see this dot here? It means I have to go through here, follow that, go through this point, and go up. Now, the reason I know I have to go through this point is because that's to the first power, and we go through the point. Finally, got to get one number over here. So you pick any number you want. How about -1? So one more time, I'm going to plug in a number. -1, or 2 minus -1, -1 squared plus 1, -1, -1 minus 6, -1 minus 4. So that becomes 3, 2, -7, and -5. So it's 6 over -35, so it's a negative. So I know it's a tiny negative. 6 over 35. So I know I can't go up because I'm not allowed to hit the x-axis, so it's got to go down here, and over here it's got to asymptote. So that's what the picture looks like. Oops, I think I moved the camera. There we go. Now at this point, let's see, sketch that along. What is the asymptotes? And I believe I also asked for the domain of this guy. So let's talk about the domain. Maybe a different color. Right? Domain is how far to the left do we go? Well, I'm going to negative infinity. And how far to the right do we go? See how we have a vertical asymptote here? Well, that means I get to 0, and then there's a break. And what you guys should be putting in are U's. That's a union. Then we go from 0 to 4, or we can be between 4 and 6, or 6 to infinity. So this huge mess here is the domain, and that's rational functions. So I'm going to stop there. This is the first 4 questions in the review packet. Some of it you should have been able to do. Now what I want you guys to notice is the next section, right, is a whole lot of trig, which you guys haven't seen since the fall. So I'm going to stop here with this video. The next video is going to be me going through a bunch of the next bunch, which I'm not going to have you do ahead of time. I'm just going to do it, and we'll see how it goes.